what's going on in it. You all following that? So, you know, be kind to yourself. So these scales, if this was true, then when I started to collaborate with Dr. Rauscher, you know, which was one of the only physicists that would actually work with me. I'm just kidding. You know, somewhat. And she was retired. She didn't have anything to lose. So, you know, she said, if you're right, I think you're insane, but if you're right, then we should be able to write a scaling law that shows that the vacuum divides in a very specific way. And so we wrote a scaling law where we, you know, we plotted the radius of an object relative to its frequency, to its energy level. And we plotted all the things in the universe on it that, you know, the large things and the small things. And we started with the universal size. Now, I just want to let you know, if you take the size of our universe and you put all the mass we see in the universe, which is 10 to the 55th grams, right, in it, our universe obeys the condition of a black hole. That is, there's too much mass for light to escape it. We know since Einstein that light gets curved by gravitational fields. You know, we were able to show that with stars that are behind the sun that appears to be beside the sun just because the light is curving. And so if you shine a laser at night, the laser is going out and is being curved by the sun a little bit. And it's going to get curved by another star a little bit, and another star, and another star, and another star, and it's not going to come out. It's got too much mass in our universe. We live inside a black hole. This is why it's black at night. That's another story. And why is that? Well, because remember, if it's division to infinity, and each division has mass, then everything must be a little singularity of infinite density. Everything must be a little black hole. Every atom you're made of. So when I made this calculation, I was very happy to see that that matched. The mass of the universe to its radius gives the exact equation for a black hole density. And then I looked at quasars and galactic centers, and I plotted those, so their energy level to their radius, and they started lining up. And then I plotted stellar object, and it lined up too. Now there's nothing in cosmology that would predict that this should happen. And then I plotted the atom. So now that's a big jump from the sun to the atom, right, across quantum theory. And sure enough, the atom showed up along that line, and this is the Planck's distance. So everything lined up along that line, and this is the Planck's distance. So everything lined up nicely. And then I looked at the biological entity and found that microtubules, which are little structures that makes up your cell's boundary, okay, oscillate at 10 to the 11 to 10 to the 14 hertz, and when you plot their size, it almost bisects perfectly this, you know, continuous line from universal size, the size of the universe, to billions of times smaller than an atom. Everything lined up, including biology, which is you. You are in that mechanism. You are part of this conduit of information of the vacuum that goes from infinitely big to infinitely small through you. And as it passes through you, it picks up your specific interpretation of the universe and feeds it to the infinity of all things, so that your participation is counted. Do you start to get a sense of your responsibility? And so there, you know, we start to feel that connection to all of the scales. But how do we get that feeling of that connection? Just a little side note on philosophy. We get that feeling of connection not by trying to connect with infinitely big. People say, I can't visualize that. Well, that's because your senses are fairly limited. But you have the infinitely small within you. So through that direction, you can connect to infinity. This is why most of the masters that have walked the earth have said, go within. The kingdom of heaven is within. You know, the Buddha is within everything. The Bindu point is within everything. And it's your connection to all knowledge. Right? Right. Oh. You're all going, oh man, you mean I've got to sit in like some pretzel position every morning and like, oh. No pretzel necessary. You can do this sitting down anywhere, or standing up if you want to. You have access to senses towards the infinitely small. Because you contain it. But you know, when I wrote these equations, there was an issue. One of it was like, okay, if everything is different scales black holes, when I presented that to physicists, I got my butt kicked pretty hard. Typically kicked out of physics conference. Why? Because, you know, I've got an atom in there that I'm saying is a black hole. Is the atom really a black hole? And that brings us to that paper I just published that's so controversial. And I assure you, I'm still dodging plenty of tomatoes and rotten eggs. Right? That paper is called a Schwarzschild proton, and it's kind of a bombshell. In very simple mechanical equations that I'm going to show you right now, I prove that the atom is a mini black hole. And how did I do that? Well, I looked at it this way. I said, I'm not going to do like everybody else and ignore the density of the vacuum. Okay? I'm not going to ignore the most intense, the most energetic, probably the source of everything, thing that we found in physics. So I said, inside a proton volume, right? The proton is like, let's say you have a simple hydrogen atom, you have a little proton, is the nucleus of the atom. It's very, very tiny in the middle. I said, inside there, how much volume is there? And so I calculated the volume of a proton. It's 10 to minus 39. Depending on which radius you take, it's an approximation. 10 to the minus 39 centimeter cube. And I said, how much of this energy that's in the vacuum is still present inside the teeny weeny beady proton? And I made the calculation, which is pretty straightforward. And the result is 10 to the 55th grams within a proton volume. There's still 10 to the 55th grams inside the volume of a proton. Where did we see that number? The mass of the universe. The mass of the universe. Now remember our assumption, remember our statement? The vacuum connects all things. If that was true, that would mean that you'd expect all the information of every proton in our universe to be present in each one of them. And that's exactly how the math came out. Isn't that cool? This is actually the mathematical evidence, I'll call it for now, that everything is one. Alright? Now, no longer just a concept, no longer a dogma, now it's a mathematical, physical evidence. Like that? Yeah, right on. I thought that was cool. I didn't mention it in that paper. I didn't talk about oneness, you know. Don't want to be too obvious in those papers. I said, oh, you know, this number is evidence that all protons are entangled. Right? You know? If you use physics terms, then they'll listen. And so, this is all nice, you know, this 10 to the 55th gram per proton volume. Remember, 10 to the 55th gram is enough to make the whole universe a black hole. So obviously, if I take all of that as the mass of the unit of the proton, no doubt the atom is a black hole. But actually, how much of that do I need to take? Very little. In fact, if I only use 10 to the minus 39%, a very teeny, weeny, beady little amount of 10 to the 55th grams of energy, the proton becomes a black hole. The atom is a black hole. And so in this paper, in some ways, you could say that I'm saying that the vacuum is feeding all atoms. That the material world is basically 10 to the minus 39% of the energy of the vacuum. It's just a little bitty weedy leak, teeny weeny leak of the vacuum. And it makes up the material world. You all followed this? So imagine if we tap this energy that's in space everywhere, we don't even need to tap anywhere close to 10 to the minus 39% of it. You know, if we tap if we cohere that energy, get it to work with us just a little bit, just a teeny weeny bit, we produce enough power to power our whole planet for thousands and thousands of years. We can produce enough power to create gravitational fields, gravitational drives, travel across our solar system, travel across our galaxy, probably go from one galaxy to another or even one universe to another. We free our society from the bounds of being stuck to the surface of a planet, which is not a really good place, you know, which was one of the only physicists that would actually work with me. I'm just kidding. You know, somewhat. And she was retired. She didn't have anything to lose. So, where we, you know, we plotted the radius of an object relative to its frequency, to its energy level. And we plotted all the things in the universe on it that, you know, the large things and the small things. And we started with the universal size. Now, I just want to let you know, if you take the size of our universe and you put all the mass we see in the universe, which is 10 to the 55th grams, right, in it, our universe obeys the condition of a black hole. You know, she said, if you're right, I think you're insane, but if you're right, then we should be able to write a scaling law that shows that the vacuum divides in a very specific way. And so we wrote a scaling that's going on in it. You all following that? So, you know, be kind to yourself. So these scales, if this was true, then when I started to collaborate with Dr. Rauscher,